let us look at the what? The application of hyperconjugation. Application of hyperconjugation. Are we? So the hyperconjugation, I said it has three functions. Number one, it results to shortening of bonds. Yes, it's a result to the what? To shortening of what? Of bond? Of bond. Let me explain this with, yes, one carbonium what? Ion. Take this compound as case of study. As though we have what? I've used this before. We have R attached to the carbon. We have hydrogen here, alpha hydrogen bond with what? This carbon and what? CH2. We have plus here. This is alpha carbon, Abi, and this is what? Alpha hydrogen. The shifting of alpha and what? Hydrogen to what? So this empty this to have shifting of alpha hydrogen to the empty p orbital here is called what? Hyperconjugation. You will now have what? R. What? We have a key into the empty hydrogen and how? We have C plus. No, sorry. C R what? So this is coming here. We have double what? Double bond. CH2. Good. And here we have what? A positive. It has loose its electron. This is the empty what? Hydrogen. Yes, observe here. You can see between these two carbon is a single bond. If the bond length we have here, assume is 0.7, is an assumption. So once this bond is come to this side, it's become a double bond. The bond length here will be 0.3. So, and the shifting of this sigma bond, so this empty p orbital here, carbon here, is called hyperconjugation effect. Abi now? So when this bond come to this side and become double bond, the bond length here will reduce. As the number of the bond increases, this bond length will reduce. So the hyperconjugation results to the shortening of the what? Of the bond length. So the number two is what? Is explain the stability of a compound. And we know that is what? It's what? It explain or it's account for the stability of a compound. And from here to heaven, the hyperconjugation effect can be found in three compounds. I've said it before. I said the first one is what? Carbonium ion. Second one is what? Is alkene. Abi. The third one is free what? Radical. So, and I abbreviate it to the what? To the one we call CAF. Abi. So now I need to what? To explain the stability of what? Of carbonium ion in what? The first one? Carbonium, the stability of what? Of stability of carbonium ion by hyperconjugation of alkene and what? Free what? Free radical. The first one now, let me to what? To account for stability of what? Of alkene. Or I should account for stability of carbonium ion first. Yeah. Number one. It is used to it is used to account for stability of what? Carbonium ion. What is carbonium ion? Carbon containing compound. Look at this compound now. CH3 Let me put it CH3. Good. CH3. This carbon carry positive here. And we have what? CH3. C. And the second one, I'm having CH3, CH3, we have H here. The third one, I'm having CH, CH3, this is also ion. CH, we also have ion here. The next one, I'm having H, I'm having H, I'm having H here. Look at this. All these compounds, they are carbonium ion, carbon that contain positive ions. Good. Please don't forget my alpha hydrogen and alpha what? Carbon. Please, this carbon here is functional group. No be so? This carbon here is functional group. This carbon here is functional group. This one here is functional group. Good. So if this is functional group, how many carbon attached to the functional group directly? Here we have 3. Am I communicating? So any carbon that is attached directly to the functional group are called alpha carbon. So here we have alpha carbon, we have alpha carbon, alpha carbon. So we have how many alpha carbon here? 3. And each alpha carbon contains how many hydrogen? 3, 3, 3. Multiply the alpha hydrogen we have here. 3 times 3 is 9. So here we have what? 9 alpha hydrogen. Don't forget, I said the number of alpha hydrogen in the compound is equal to the what? The number of what? Of resonance structure that the compound we have. So if we are going to draw the resonance structure for this compound, we have 9 structures. Abi, I said what? The increase the number of what? Alpha hydrogen lead to the increase in number of what? Resonance structure lead to the what? The increase in stability of the compound. Abi? Okay, look at this one now. How many alpha hydrogen? 1, 2. Alpha carbon 2. Then 3, 3. Alpha hydrogen here is what? Will be 6 alpha hydrogen. This one we have 6 resonance structure. Here, how many alpha hydrogen? We have 3 alpha beta abi 3 alpha what? Hydrogen. So this one we have how many structure? 3 structures. Where we have how many alpha hydrogen? No alpha hydrogen here. There is no carbon attached to this one. Abi? And as the number of alpha hydrogen is increases, is the number of what of resonance structure is increases and stability increases. In terms of stability now, apply this. Which of the 3 compounds is what is most stable compound? The one that is have higher number of what of alpha hydrogen. So therefore, this what tertiary what? This is tertiary carbon. This is secondary carbonium ion. This is what primary carbonium ion. So this is what is more stable than this. This is more stable than this. This is more stable than this. This is what the least stable compound. That's how we can use what? The hyperconjugation effect to explain the stability of carbonium ion. Good. The next one, other stability, we are dealing with CAF, alkene, abi, is used for the stability of what? Of carbon, of alkene, abi, is used for what? Stability of our what? Alkene. If you want to explain the stability of alkene, it's almost the same with what? With what I've explained since. For the alkene, look at this compound now. If you have a alkene compound in this form, triple bond, triple bond, triple bond, triple bond, and triple bond, good. And I may also have another alkene like this, triple bond, triple bond, triple bond, H. We also have it in this form, triple bond, triple no H, and we have triple bond, we have H. Good. If we have it in this form, triple bond, we have H, triple bond, and H. Yes. We are now asked which of these compounds is the most stable compound. That is application of what? Of steric effect. Try to locate the alpha carbon and alpha hydrogen. What is alpha carbon? Carbon that's attached directly to functional group. This double bond here, this double bond here, they are the functional what? Group. 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 Good. So the hydrogen that attached to the carbon are called alpha hydro what? Hydrogen. So here now we have for this place, we have how many alpha carbon? 1, 2, 3, 4. How many hydrogen here? 3, 3, 3, 3, 3, 4, 12. So here we have what? We have 12 alpha hydrogen. Here, calculate this one. We have how many alpha? 1, 2, 3. Alpha carbon. Good. How many hydrogen? 3, 3, 6, 9. So here we have what? How many alpha hydrogen? We have 9 alpha hydrogen. So look at this one too. We have how many alpha carbon here? 1, 2, hydrogen. 6. We have 6 alpha hydrogen. Here we have how many carbon? Alpha carbon. 1. So how many hydrogen? We have what? 3 alpha hydrogen. Good. Once you know this, any one of them that is about the highest number of what of alpha hydrogen must be most stable compound because it will also have what the highest resonance structure. I said the I increase the number of resonance structure, increase the stability of the what of the compound. As a result of that, what are we going to have now? So this compound is most stable, followed by this, followed by this. This is what? The least stable. Am I communicating? The last aspect for today is to explain the what? Stability of free radicals. Stability of what? Of free radicals. To explain the stability of free radical is almost the same with what? With this. If you have what? The same with this one. If you have CH3 like this, CH3, CH3, we have free radical here instead of the plus. And we have what? CH3 here, we have hydrogen. If I'm having CH3, hydrogen radical, I'm having what? CH, H, H radical. This is almost the same with what? What I explained here. So this one we also have what? 3 alpha, alpha carbon, alpha carbon. If you add it together, well, the same with what? What we have here, 9 alpha hydrogen. So here we have what? How many alpha? How many? 1, 2. Here we have 1. So if we have it in that form, so how many hydrogen attached to 3, 3? We have what? 6 alpha hydrogen. We have 3 alpha what? Hydrogen. Good. So what happened to stability? This is what? The most stable. Most stable. This is the least stable. So this is most stable. This is least stable. The stability is what? Is going like this, increase. If come like this, is what? Decreases. So that is the stability. And don't forget, you can also use what? Inductive effect to explain this. Do you know? Check it. You can use inductive effect to explain this. If you use inductive effect and you use hyperconjugate effect, you must get the same what? The same answer. So this is where I'm going to stop for today. In my next video, I'm going to what? To move to the steric effect, steric effect reaction mechanism. Please don't forget to like, share our video, comment, and subscribe. Thanks for watching.